today we're going to talk about the best method to solve systems of equations, but I think at first let's talk about some special cases. So, if two lines intersect, they intersect at exactly one point, which means we have one solution. If two lines never meet, then when you're trying to figure out or use elimination or use substitution, sometimes you get an answer that makes no sense. If it makes no sense, it's no solution. Sometimes you get an answer that's obvious or identity, right, Philip? When I get that, I know that it's the same line. This is infinite solution. So let's determine the best method to solve each system. I think we did this yesterday. Let's do it real quick again. We don't need to use clickers. It took too long in the last period to do it. What would you use for this one? Raise your hand if you know. Okay, Matt? I would use substitution too, right? I would substitute 8 back in here where y is and solve. What about, let's go to this one first. Not that one. Caden? Elimination with multiplication, that would work. Good. What else could you use? Substitution, right? How would you use substitution? Add 3y to both sides, then you got an x equals, right? Solve for one variable. What about this one? Somebody new.
Substitution.
Substitution, Selena says, right? Why?
Because it already has y equals.
It already has y equals. Number 4. Somebody new. Okay, let's hear it. Good. You could graph that one, right? They're both in slope-intercept form. What else could you use? Substitution, right? You could say if 3x minus 17 equals y and negative 2x plus 18 equals y, if they both equal the same thing, aren't they the same? Yeah. Yes. Somebody new. Waiting for new hands. Okay, Philip. Oh, there's something easier we could use in substitution on this one. Johnny? Elimination with addition, right? They're already set up for you. See that, Philip? Look at that. They're already set up. Hey, what happens when we do this one? What do you get? 0 equals 2. Does that make sense? No sense means no solution. Good job. All right, so best method. I'm going to come up with a plan. My plan is I have one variable that is already solved for me, right? So I'm just going to use substitution. 4x's minus 2y's equals 8. I already know what y is. Y equals 8. So I have 4x minus 16 equals 8. Add 16 to both sides, and I get 4x equals 24. If 4x's is equal to 24, how much is 1x equal? 6. Then I substitute it? You'd think so, huh? That's exactly what I would go to. That's what I did last period. I went, okay, and now we need to substitute, right? I don't want to substitute in there. I'm going to substitute in here. Anybody going to stop me? Oops. No, nobody's going to stop me? Really? Too tired, huh? 4x's minus 2y's equals 8. I'm waiting. I already know what y equals. See, sometimes you get so busy doing what you're supposed to be doing that you go back and look at the obvious. Don't we already know what 8 equals? Sorry, what y equals? So we already know the solution to that, right? So the intersection is, what is it? Why is this not? Oh, I'm not hitting the right one. Duh. 6, 8. I'm going to give you a chance to write this down, and I'm going to uncover our steps here. Come up with a plan. I came up with a plan, right? I said I have one variable that's already solved, so I'm going to substitute. So here's your guidelines. If both are solved for y, you can either graph or substitute. If one is solved for a variable, substitute. If neither are solved for a variable, eliminate. Let me give you guys a little bit to write that down. You guys try this one on your own. Come up with a plan and solve. Okay, so how about Carlos? Carlos, what method did you use? You use substitution. That's what I would use too. So I'm going to say negative 15x plus 3y. Well, I already know what y is. Y is 5x minus 4. So I'm going to make sure I have enough room to fit that in there. Equals 1. So if 5x minus 4 equals y, I can put that right here. Then simplify, I get negative 15x. If I distribute, I get positive 15x minus 12 equals 1. Don't these make 0 pairs? Let's cancel each other out. Then I get negative 12 equals 1. Does that make sense?
No.
No sense means no solution. Questions on how I did that? There's more than one way to do this one, right? Did anybody use a different method? No? Okay, let's move on to the next one. Why don't you guys try this one on your own? Okay, so how about Dylan? Dylan, what did you choose? You did elimination multiplication. Okay, so what did you do? You multiplied everything in the numerator by 2? Awesome. Okay, what did you get when you did that? Equals 6. Good. And then in this bottom equation, don't I have the inverse of every single one of those? So all of these are 0 pairs. So what are you left with? What's on this side? Nothing. What's on this side? Nothing. Nothing equals nothing is infinite solution. Not no solution. That means these are the same line. What else could you have done? Anybody do something different? Andrew? You use substitution. Good. Anybody use something different? Matt? You know what I saw? I saw already that these all look like they have something in common. I divided everybody by 2. If you divided everybody by negative 2, negative 2x plus 6y equals negative 6, watch what happens. Divide everybody by negative 2, what do I get? X minus 3y equals what? 3. Aren't they the same line? See that? Same line. Infinite solutions. Lots of different ways to look at this, right? Okay, try this one. Okay, how about Brandon? Brandon, what method did you use? You graphed it. Awesome. I don't think I'd want to graph because of the 18 and the negative 17. Did somebody do something different? I mean, you could totally graph, but Carlos, what did you do? You use substitution? So the top one, perfect. They equal each other, right? If they both equal y, they both equal each other. Then I could just add 2x to both sides, and while I'm adding, I might as well add 17 to both sides as well. What do I get? 5x equals 35. If 5 x's are equal to 35, what is 1 x equal to? 7. What do I do from here? Which one do you want to substitute back into? Top one? Okay, yeah, that'd probably be easier. So y equals 3 times whatever x is minus 17. I know x is 7. So y equals 21 minus 17. What's that? Y equals 4. So therefore, the intersection is what? 7, 4. Uh-oh, that's not a 7. Whoa. That's crazy. Better? 7, 4. Questions on that one? No? Moving on? Okay, try this one. Okay, let's see. How about Lauren? Lauren, what did you use? Elimination by addition, right? This cancels out. This cancels out. What are you left with on this side? 0 equals 2. Does 0 equal 2? No, that makes no sense, so it must be no solution. All right, great job, guys. Okay, let's see how well you guys do this. Freeze. What did you learn today? Okay, I need a hand. I saw Clyde's first. What did we learn today? Not exactly correct, but what, hey, I said freeze. I'll keep you in at lunch if you can't freeze. Do we need to practice freezing, Levi? Okay, just making sure. Clyde, what did we learn? Best method. What else did we learn? Philip? Huh? We learned about some special cases. Caden?
We learned like if both of the sentences look like whatever. If they're both something equal, if they're both the same letters.
Oh. Yeah, that was something new for you? So if they're both equal to y, then they're both equal to each other?
Yeah.
Perfect. What if they're both equal to x? They're both equal to each other. Andrew? If everything cancels out, well, two things happen, right? If all the variables cancel out, we can get infinite solutions, right? If some of the variables cancel out and the constants don't cancel out, then we get no solution. So a couple of different things that we looked at, mostly just special cases. What about this? When is substitution the best method to use? Lena? Not just y. When you solve for just one specific variable, right? When you have one variable equals, you know you can use substitution. The person next to you is absent. How would you explain why all solutions have two numbers listed as an ordered pair? Why would that be? How come every time we solve one of these, we get an ordered pair? Somebody other than Caden. Caden, pick somebody, or you don't know everybody's name yet.
I don't know Matt.
Okay, Matt.
I heard the first question.
Okay, so how come we keep getting these ordered pair solutions? It says the person next to you is absent. How would you explain why all solutions have two numbers listed as an ordered pair?
Oh, okay. Because they all have an intersection.
Because they all have an intersection, exactly. All right, so here's your cue, Levi. On your assignment sheet, I would use the blank method to solve the system because this could be a few different things, right? They don't have them back yet? Okay. All right, let's get started on homework then, and then Jeremiah is going to get your papers back to you.